Good morning, everybody. Today we're going to start our third and final form of equations. The third and final form is called standard form. Ooh, that was bad. Hold on. Let me try that again. A little bit better. Alright, standard form. So we have our three forms. We have y minus y1 equals m times x minus x1. That is point slope form. We have y equals mx plus b. That is slope intercept form. And finally, we have ax plus by equals c, where a, b, and c are different numbers. This is standard form. So if we use these points, 4, 7, and 5, 1, and we put them into our different forms of equations, well, they already did this for us. They put either, if we use 4, 7, this is the top one, or 5, 1 is the bottom one. They found our slope was -6. So we can use either of these equations for our point slope form. Now point slope form it can be converted to slope intercept form. And how it does that is if we use this top one, y minus 7 equals -6 times x minus 4. Well, if we distribute this, -6, get y minus 7 equals a -6x. -6 times 4, or -4 is plus 24. Then all we got to do is get y by itself, so we're going to add 7. So y equals a -6x plus 31. And that's what it came out with, y equals -6x plus 31. Now, how we get it to standard form, though, is if you notice, the x and the y are on the same side. So if we take y minus 6x plus 31, all we got to do is move our x over to the other side to get it with our y. So we're going to add 6x to both sides. Now because I can't combine x and y, all it does is stay 6x plus y equals 31, which is what they got here. Now standard form can be converted to slope-intercept form, and slope-intercept form can be converted to standard form, but standard form and slope-intercept form cannot be converted to point-slope form. So once you have these two, you can't get point-slope form without some more information. But point-slope form can always be converted to slope-intercept, then slope-intercept can be converted to standard form. So this one says write two equations in standard form that are equivalent to the given equation. Well, we have 5x plus 10y equals 15. We're trying to write another equation that's the same as that would be the same no matter if we simplified it or increased it. Now, what I see is that each of these can be divided by 5. They're all multiples of 5. So what I can do is I can divide by 5. 5 divided by 5 is going to give me 1x. 10 divided by 5 is going to give me 2y. And 15 divided by 5 is going to give me 3. So this is one of the equivalent equations. It means the same thing even though there's different numbers. Another thing we could do is we could just multiply these all by a number. It doesn't matter which, as long as we do everything. So I'm going to multiply it by 2. 2 times 5x is going to give me 10x. 2 times 10y is going to give me 20y. And 2 times 15 is going to give me 30. If I reduce these all, they would give me 5x plus 10y equals 15. Same thing over here. I'm going to start by multiplying by something. Let's say we're going to multiply by 3. So I'm going to multiply 3 by negative x, so I get negative 3x. 3 times 2y gives me 6y. And 3 times negative 9 would give me a negative 27. Now another thing I could do here is I could, we could divide everything by 2 if we wanted to. That's one way to do it. If I divide by 2, negative 2 divided by negative 1, or positive 2 divided by negative 1x gives me a negative 0.5x. 2 divided by 2 gives me 1y. And negative 2 divided by negative 9 gives me a negative 4.5. Alright, this says write an equation in standard form of the line that passes through the given point and has the given slope m, or that passes through the two given points. Well, here I have a point and I have a slope. Now just by saying that, it told me that I have a point x1 and y1 and a slope 3. So I can write it first in point slope form. So y minus y1, which is negative 1, which we can make a plus, equals m, which was 3, times x minus x1, which is 4. Now, this is point slope form. We're going to have to convert it to get standard form. So the first thing we need to do is we can't go straight from point slope to standard. We need to convert it to slope intercept first. So I'm going to distribute my 3 and get y plus 1 equals 3x minus 12. Subtract 1 from both sides, and we get y equals 3x minus 13. Now this is slope-intercept form. How we get it to standard form is all we need to do is move our x over to the other side. So I'm going to move this 3x by subtracting it. And because I can't combine x and y, I just get a negative 3x. The y is positive, so plus y equals whatever we have left over here, negative 13. So this is standard. Here again we have a point, x1 and y1, and we have a slope of 1/2. So we have y minus y1, which is negative 4, equals 1/2 times x minus a negative 15. We can make these into plus. Now we have, this is point slope. I'm going to get it to slope intercept. So we have y plus 4 equals 1/2 x plus half of 15, which is 7.5. Subtract 4 on both sides. And we get y equals 1/2 x plus 3.5. Now that's slope-intercept. And finally, all we need to do is move over our x. So I'm going to subtract 1/2. So we get negative 1/2 x plus y equals 3.5. Now this is standard. Alright, now this one says write an equation in standard form of the line that passes through the given point and has the slope m, or that passes through the two given points. Well, we know that we have 2 points, so we know that we have a x1, a y1, a x2, and a y2. So what we have to do first is find our slope. So it'll be negative 3 minus a negative 1, 2 minus 3, negative 3 plus 1 gives me a negative 2, 2 minus 3 gives me a negative 1. We can simplify that down to just 2. So our slope is 2. Now we can write this in our slope-intercept form if we want to. So we have y equals 2x plus b. Now we need to find out what b is before we do anything. So all we need to do then is just substitute one of our points. So I'm going to pick 3, negative 1. I'm going to put negative 1 in for y. And for x, I'm going to put in 3 plus b. So 2 times 3 is 6 equals negative 1 plus b. Subtract 6. And b equals a negative 7. So now that we know b, we have y equals 2x minus 7. All we got to do is move the x over to the other side. So subtract 2x. And we get negative 2x plus y equals whatever we have left, which is negative 7. Here again we have x1, y1, x2, and y2. Our y2 is negative 5 minus our y1, which is 6. Our x2 is negative 12 minus our x1, which is 10. So negative 5 minus 6 gives us a negative 11. Negative 12 minus 10 gives us a negative 22. We can simplify that down to 1/2. So I'm just going to write our slope-intercept form. Equation y equals 1/2 x plus b. But I'm going to pick 10 and 6 to put into our equation to find b. So 6 is our y, equals 1/2 times 10 plus b. Half of 10 gives us 5. So I'm going to subtract 5. And 1 equals b, or b equals 1. So y equals 1/2 x plus 1. All we got to do then is move the x over, so subtract 1/2 x. And we get a negative 1/2 x plus y equals 1. And these are our standard forms. Alright, so this one says write equations of the horizontal and vertical lines that pass through the given point. Our given point is -3, -4. So we're going to go over to -3, 1, 2, 3, and down to -4, 1, 2, 3, 4, and there's our first point. Now what it wants us to know is what the horizontal equation is for that. So when we say horizontal, we mean a line that's going straight across like that. Now, we know that this is never going to cross our x-axis, but it does cross our y-axis right here. So basically what this is we count down how many it goes down the y-axis, which is 1, 2, 3, 4. So our horizontal is y equals -4. That's our equation, which is y equals -4. The vertical, it goes straight up and down instead of side to side. So this never crosses our y-axis, it's on our x-axis. So this is at -1, 2, 3. So our x equals -3. Over here, if we count out our point, we have 1, 2, 3, 4, 5, down, -1, 2, 3, 4, 5. So we're going to look for our horizontal. Our horizontal goes side to side through our point. This crosses our y-axis, so y equals a -5, because it's at -5. Then our vertical is going up and down. So our vertical then is x equals 5. Alright, let's go on to our last slide. It says tell whether the graphs of the two equations are parallel lines. So what we need to do is put these both into our slope-intercept form. Right now they are not in any form. So if we put them in the slope-intercept form, we got to try to get y by itself. This will be the easiest form to tell us what our slope is. So I'm going to add 12 to both sides. Now remember, parallel slopes have this, or parallel lines have the same slope. So that's what I'm looking for here. I'm trying to get both of these to have the same slope. If they do, they're both parallel. So divide by 4. When I divide by 4 and there's multiple over here, I divide everything by 4. So we get y equals 12 divided by 4, which is 3, plus 8 divided by 4, which is 2x, Now if I rewrote this into our actual form, y equals 2x plus 3, our slope would be right here, and that is 2. So our slope here is 2. On this one, I'm just going to move over the 8. So I'm still trying to get y by itself. So we have 2y equals negative 4x minus 8. Divide by 2 to get y by itself. And y equals a negative 2x minus 4. Our slope for this one is m equals negative 2. Now they're very close, m equals 2 and m equals negative 2, but they're not parallel because they don't have the same slope. Alright, your homework for this lesson is page 314, numbers 1 through 3, 5 through 7, 11 through 21 odd, 23, and 25.